Now talk about the difference between parallel computing and distributed computing. Sometimes people confuse, not sometimes but oftenly, people confuse between these two terms and consider both as a same. But there is quite difference between parallel computing and distributed computing. So let's talk about the parallel computing first. So parallel computing is the process of performing computational tasks across multiple processors at once to improve the computational speed and efficiency. So in parallel computing, different processors work in parallel uh, against a particular task, and the goal is to improve the speed and efficiency. So it divide tasks into subtasks, or we can say divide process into tasks and subtasks and execute them simultaneously through different processes. So if we look to the modern computer systems, uh, they all are mostly designed on parallel computing. So this means the modern technologies, core systems, Core i3, Core i5, Core i7, and Core 2 all are based on parallel processors. And the agenda is to work on same task, some task, and then they main ultimate goal is to improve the speed. There are three main types or levels of parallel computing: bit, instruction, and task level. So types of parallelism. Bit level parallelism. It is the form of parallel computing which is based on increasing the processor size. So how we can do that? If there is a one processor with some size, dedicated size, so we cannot increase that particular processor size, but we will embed a processor in parallel to their processor. So this means the bit size will be automatically increases. So bit level parallelism reduces the number of instructions that the system must execute in order to perform a task on a large size data. Let's take an example. For example, we have 8-bit processor, and in this scenario, 8-bit processor must compute the sum of two 16-bit integers. So how 8-bit processor will compute the sum of the 16-bit results? Remember that 8-bit processor can handle 8-bit integer at a time. But if we have to add two 16-bit integer, so it is obvious that first lower 8 bits will be added, and then the carry number of those two 8-bit number will be added with the two higher order bits. So this means uh, uh, the computational speed will be decreases because the number of instructions are more are increased. If we add two 8-bit numbers on 8-bit processor, and on the other side if we add to 16-bit number on same 8-bit processor, so the 8-bit processor which are adding to 16-bit number will take double instruction time. So a 16-bit processor can perform the operation with just one instruction instead of two. How? By adding one more 8-bit processor. So if instead of one processor, if two pair processor are working on this scenario, so it will take only one instruction instead of two. So this means computational speed is increased and time is reduced. Now, the second is instruction level parallelism, simultaneous execution of multiple instructions from a program. Uh, Instruction level parallelism or ILP refers to the capability of processor to execute multiple instructions simultaneously, taking advantage of independent instructions and reducing dependencies between them. So instead of executing instruction in series one by one, so if we divide the program we divide the program into tasks such that assign some instruction to one category of task or one processor task and some to other. So this means the time will be reduced, but remember that there should be no dependencies between the instructions. Task parallelism employs the decomposition of tasks into subtasks and then allocating each of the subtasks for execution. So let us suppose if we have a big task which comprise of six subtasks. So if we divide the big task into 3 3 or 2 4 based on the subtask size. So obviously every subtask have no is not same in size as compared to other subtasks. So if we divide and then assign both tasks, assign half task to one processor and half type, for example, to other processor. So this means there is a task parallelism. So the task can belong to one program or task can belong to more than two programs. For example, if the processor is executing multiple programs, different programs, the task can belong to different programs at a time. So we have three types of parallelism: task parallelism, bit parallelism, and instruction level parallelism. So in bit, we do parallelism of the bits, and then we divide the instructions that work in parallel, and we divide in tasks in parallel. Advantage of parallel computing over serial computing are as follows. It saves time and money as many resources working together will reduce the time and cut potential cost. It can be impractical to solve large program on serial computing. So what is serial computing? Obviously, in serial computing, one task cannot start it as other task is not finished. So if there are three tasks, so after finishing task 1, task 2 will be started, and then after finishing task 2, task 3 will be started. So obviously it will take a time, but compared to parallel computation, some tasks, let's suppose task 1 2 are assigned to processor 1 and task 3 is assigned to processor 2, or task 1 is assigned to processor 1, task 3 can be assigned to processor 3, and task 2 can be divided into subtasks such that some subtasks are assigned to processor 1 and some to processor 2. So by doing this, the computational speed increases and latency decreases. Serial computing wastes the potential computing power, thus parallel computing makes better work of the hardware. So obviously when the instruction or computation takes more time, so obviously it will consume more power and it will require more computational energy. So this is the advantage of parallel computing. Now, in contrast to parallel computing, there is another term which is distributed computing. So distributed computing is the process of connecting multiple computers via a local network or wide area network so that they can act together as a single computer. So in distributed computing, we have two different nodes or computers such that both of the computers have their dedicated processor or processors. For example, if distributed computing is consists of two computers, so both computer can have one or many processors. So this means in distributed computing, we distribute the whole computer, while in parallel computing we have only one computer with many parallel processors. So this is the big difference. Distributed computers offer two key advantages: easy scalability and redundancy. So how? So it provides easy scalability. Just add more computer to expand the system. So this is the advantage of this distributed computers. And redundancy is since many different machines are providing the same service, that service can keep running even if one or more computers goes down. So this is obviously discussed in detail in our last lectures of distributed computing. Actually this course is about the distributed computing, not on the parallel computing, but this lecture is included to differentiate between these two technologies. So remember that compared to distributed computing, redundancy in parallel computing is not easier. For that we have to change the whole architecture. So it is not easier to add multiple processors as much we wish, but in distributed computing we can easily add that many computers. And another advantage is that when one node is failed, so the overall system is not so much affected or does not fail as a whole. Parallel computing typically requires one computer with multiple processors, while distributed computing, on the other hand, involves several autonomous, often geographically separate computer systems working on divided tasks. But for a user, it distributed computer look like a one system, but it is not a one system. And the main difference between parallel and distributed computing is that parallel computing allows multiple processors to execute tasks simultaneously, while distributed computing divides a single task between multiple computers. So this is a very important point that you should know, that oftenly in distributed computing we have single tasks that are distributed, or we can say that all the distributed nodes or computer work for a single program or task. But in pair processing the task can be same, but alternately that task is also divided into subtasks and assigned to parallel computers. But parallel processors can work, as I stated earlier, that parallel processors can work on two different tasks. Task 1 is assigned to one and task 2 is assigned to another. Look to this diagram. On the left side we have distributed computing example, general example, and on the right we have parallel computing example. So in distributed computing we have four different computers: computer 1, 2, 3, 4. Each computer has a processors, or processor can be parallel processors or can be one processor with dedicated memory. And on the other side, parallel computing have one computer with multiple processors. So distributed computing and pair processing are different. So in distributed computing, one computer share communicate with another computer, and the purpose of all these computers is one, goal is one, and they all work on the single task. But here all the processors can work on the same task by dividing it into sub tasks, or can work on different tasks. Also remember that there is a one share memory. This is an important point for you to remember, that all the processor access to one share memory. But here each computer has a unique different unshared memory. One more thing, that there is no physical common clock for distributing computing, while parallel computing have a one physical clock. So this means these three processors are synchronized using a one physical clock, but these does not have one physical global clock, but rather through virtual or logical clock designed using algorithms can be created, but there is no physical clock and no one shared memory. So these are the major differences. So difference one is the number of computers required. Parallel computing typically requires one computer with multiple processors. Distributed computing, on the other hand, involves several autonomous computer working on a dividing uh, task. Uh, Dividing task means all the tasks belong to one particular task. But on the other hand, parallel computers, in parallel computing, there are multiple processors and all can work on a similar type task or can work on a different task. Second difference is scalability. Parallel computing systems are less scalable than distributed systems because the memory of single computer can only handle so many processors at once. Distributed computer system can always scale with additional computers. So I already stated this point in detail that addition of more computers to distributed computing is easier as compared to adding more processor, and it is not easier in parallel computing. Uh, Third difference is the memory. In parallel computing, all the processors share the same memory, and the processors communicate with each other with the help of this shared memory. While distributed computing system, on the other hand, have their own memory and processors. The fourth difference is on the synchronization. In parallel computing, all the processors share a single master clock of synchronization, while distributed computing system use synchronization algorithm rather than physical clock. And the fifth difference is on the usage. Parallel computing is used to increase the computer performance and for scientific computing, while distributed computing is used to share resources and improve scalability. So this is the summarized table which summarize the comparison of the parallel computing and distributed computing. When we talk about parallel computing, so many operations are performed simultaneously, and these operations can belong to one single task or can belong to many different tasks. System, while in distributed computing, system components are located at different locations. So this is another difference, that in distributed computing, computer can be located inside one building or can be geographically dispersed, while in parallel computing, all the processors are in one system. In parallel computing, single computer is required, while distributed computing uses multiple computers. Multiple processors perform multiple operations in parallel computing, while distributed computing, multiple computers perform multiple operations. So here multiple processors perform multiple operations, and here multiple computer perform multiple operations. But there is a difference between these multiple operations. Distributed, that multiple operation is for single task, and in parallel computing, that multiple operation can be for the single or can be for the different task. Parallel computer may have shared or distributed memory, and this while distributed computer have only distributed memory. In parallel computing, processors communicate using bus of the computer. Bus is a communication channel which connect two or more than two hardware parts, while computer communicate with each other through message passing using LAN or WAN. So definitely routers come here. So communication is through routers, and routing protocol are designed for that. Parallel computing improves the system performance, speed, while distributed computing improves speed as well as scalability, fault tolerance, and resource sharing capability. Here, resource sharing does not mean there will be a common memory, but here resource sharing mean one computer use another computer for task simplicity or task performance, task execution performance. And definitely scalability is also improved. And fault tolerance means that there is no burden on a single computer. So if some nodes are disabled or not working properly, so other nodes handle that task or problem. uh, Parallel computing involves the use of multiple processors with a single computer to work on a pressure problem, while distributed computing involves the use of multiple computers across a network to work together on a problem. If one processor fails, other can continue working. Uh, this means inside a computer, if one processor is not working, so the load will be, the performance will be affected, but still computer can will work. While if one computer fail, other can continue working. So remember, there is some similarity. If in parallel computer one processor fails, other will work, and here if computer fail, other will work. But in distributed computing, the performance is not affected. Can be affected if we have 10 computers and 9 are failed, so definitely will be affected, but the ratio is less as compared to parallel. So if we have 100 nodes and 2 3 are failed, so the performance will be not too much affected, the others computer resources will manage. But here the whole dependencies are on 2 or 3 processors, so if one fails, the task will be not assigned to that processor, and thus performance will be affected. In parallel computing, communication between processors is usually fast because the processors are housed with the same computer. In distributed computing, communication between computers is slower because the computers are connected to a network. Parallel computing often requires a high degree of synchronization between processors as they must coordinate their effort to solve a problem. While in distributed computing, synchronization is more complex. This is the disadvantage because computers work independently and must coordinate their efforts over network. In distributed computers, all the computers are autonomous with more heterogeneity. So two or more than two computers or using in distributed computing network are different with different quotations. So synchronization become difficult. Logical through using algorithm, synchronization become difficult as compared to synchronization in parallel computing. So when to use parallel computing? So this computing method is ideal for anything involving complex simulation or modeling. Common application for it include seismic surveying, computational uh, astrophysics, climate modeling, financial risk management, agriculture estimates, video color correction, medical imaging. So, uh, in short, all those examples fit in parallel computer where there is need of intense, where there are intense computations to solve that problem. So like video making, video editing, like in data mining, in AI applications. So mm, there can be many examples in all relevant fields which you can take. So you will rely more on the more core system. When to use distributed computing? So distributed computing is the best for building and deploy powerful application running across many different users and geographics. Anyone performing a Google search already using distributed computing. So Google is the best example of distributed computing. So different users work from their homes across the globe, and they all are connected to distributed system. Distributed system architecture have shaped much of what we could call modern business, included cloud-based computing, edge computing, and SaaS. So which is better? Now question arises, which is better, parallel or distributed? So it's hard to say which is better, parallel or distributed computing, because it depends on the use case. If you need pure computational power and work in a scientific or other type of highly analytics based field, then you probably should select the parallel computing. You should go with the parallel computing. If you are in need of intense computation, if you need scalability and resilience and can afford to support and maintain computer network, then you probably should go to the distributed computing. So both involve fast computation of tasks, but again the question arises that either that user can afford distributed computer network, can as the we should also look to the problem nature. So if the problem can be solved on one computer with using multiple parallel processors, so we should go with that rather than should establish a distributed computer network. And then if we look if we compare the scalability, so obviously distributed computer is more better. It can handle more computers with more users. So if there are more computers, this means there will be more users that will be connected to distributed computing network. But again, either the user can accommodate that. So if they can, and so they should go with the distributed computing. So this was all about the parallel computing, and then we have compared parallel computing with the distributed computing. So thank you so much for watching the video.